Hello 20-2 students. So today we are looking at lesson 4.2, adding and subtracting radicals. So if you remember in 4.1 we just learned how to simplify radicals, and now we're going to be doing operations with radicals. Usually before you do operations you have to simplify first, so we'll be using that first lesson quite a bit, so make sure that you have that simplification process down really good before you get into these lessons. So when you're adding and subtracting radicals, the first thing is you can only combine like radicals. So just the way if we were adding together like algebraic terms, for example, like if you had 4x squared, you could add it to 3x squared, but you could not add it to 3x because the terms are not the same, right? So the same thing is true with radicals. And so in order to have like radicals, they need to have the same index. So they both have to be like square roots, or they all have to be cube roots. But the index needs to be the same and the radicand needs to be the same. So the value that's underneath the radical sign needs to be the same in order to combine them. Before you start trying to do any of these operations, you want to simplify first, and a lot of times that's going to make it so that you do have the same radicand and you can combine them. If you've simplified them all the way and they don't have the same radicand, you just don't combine them. Once you have the same radicand, you can add the coefficients and the radicand stays exactly the same. So just like with this example, if we did 4x squared plus 3x squared, we would end up with 7x squared, right? Not 7x to the power of 4. So you combine the coefficients, but the term stays the same. And the same thing is true with combining radicals. So let's give it a try here. So in our first example, we have 2 root 5 can't be simplified anymore, right? We can't factor 5 down, but we could factor down 45. So we know 45 is 9 times 5. And like we talked about in the last lesson, if we have a perfect square in there, we can square root it and move that value outside. So another way of thinking that would be to further factor 9, which is 3 times 3. Because we have a pair there, we can move the single version of it outside. So we're going to have 3 times by the coefficient that's already there, 2. And the only thing that's left underneath the radical is this 5 because we've taken out all of our other factors. So we're going to have 3 times by 2 root 5 minus 2 root 5. So basically we're going to have 6 root 5 minus 2 root 5. And so now we would just consider both of these are square roots, so they have an index of 2. They both have a radicand of 5, so we can combine them. So all we want to do is do the mathematical operation that's being indicated for the coefficient. So 6 minus 2 gives us 4, and the radicand stays the same. So our answer to that is 4 root 5. If you guys are doing something like this on a test and you are unsure about whether your answer is right, you can go ahead and do the math in there to make sure that your value is the same. So basically, in order to check this, I would go 2 square root 45. Personally, for me, I always like to hit enter just to make sure my calculator doesn't mess up my operations. Minus, and then in brackets I'm going to do 2 square root 5. Oops, sorry, that should be 2. There we go. I don't know if that would have made a difference. So I end up with 8.944 if I do it in this unmodified version. Now what I want to see is, does 4 root 5 give me that same answer? So 4 second function square root 5 gives me 8.944. So I can see that I did my calculations correctly because doing the subtraction in my calculator ends up with the same value that I get from my answer. Okay, so just make sure that's only ever a backup plan, just to make sure that you can check your solutions on a test so that you know that you have to go back and rework it if you don't get the same value. Okay, in this second one, we have multiple terms. So we're just going to follow the same steps, start out by simplifying. So 12 is 4 times by 3. 4 we can square root to 2 and move it outside. So we're going to have 2 times by the pre-existing coefficient of -3. The only thing left under the radical, because we rooted the 4, is the 3. 3 can't be factored down anymore, so plus 3 root 3. And then 20 is 4 times by 5. So we can square root the 4 to give us 2. So we're going to have minus square root of 4 is 2 times by 3. And then the only thing left under our radical sign is 5 root 5. So let's combine. So 2 times by negative 3 gave us negative 6 root 3 plus 3 root 3 minus 2 times by 3 is 6 root 5. Okay, so when we look at this, remember you can only combine like radicals. So here we have square root 3 and here we have square root 3. This one is square root 5, so we can't combine that one. So we're just going to do the operation with the first two. Negative 6 plus 3 gives us negative 3, and our radical stays the same. And then this one just stays the exact same, so minus 6 root 5, because we can't combine it with anything else. Okay, again, you can always go into your calculator and check your answers if you need to. Last one here, we have several cube root terms to combine. So let's go ahead and factor those first, because some of these are pretty big. So I'm just going to do that separately, not combined like I did in the previous one there, because that could get a bit confusing. So we want to do 2 cube root 108. What can we factor down from 108? Let's see, 108 divided by 2, we could do 108 divided by 2, that would give us 54 times by 2, so 2 can't be factored down anymore, but 54 could be 9 times 6, 9 is 3 times 3, 6 is 3 times 2. So now if we want to look at, remember we're dealing with a cube root, so we want perfect cubes, so that means groups of 3 of the same, which would be these 3 3s. And then we have 2 2s, but there's only 2 of them, so we can't factor that down anymore. So both the 2's stay underneath the sign, so 2 times 2 is root 4. And then these 3's move outside, so we're going to have 3 times by that 2 that was already there, which would be 6. So this one factors down into 6 cube root 4. Cube root of 32, let's factor that one down. So 32 is 4 times by 8. And hopefully you guys recognize or remember that 8 is a perfect cube. It cubes into 2. So that means we can move a 2 outside of our radical and then have 2 cube root 4 is what's left there. Okay, for our last one we have 3 cube root 256. Okay, so 256, let's see, I'm going to divide that one by 4. So if I do that, I get 4 times by 64 would give me 256. And 64, maybe you guys remember from the last lesson, is again a perfect cube. 4 times 4 is 16, times 4 is 64. So I can get rid of that group of 3 and move it outside and multiply it by the 3 that was already there as a coefficient. So 4 times 3 will give me 12. And I'm left with one single 4 underneath my radical, so cube root 4. Okay, so now the math I need to do is 6 cube root 4. I see that they all have the same index and same radical, so I can combine them as we see here. So 6, maybe I'll write it out. Ooh, I didn't space this out very well. 6 cube root 4 plus 2 cube root 4 plus 12 cube root 4. Okay, so 6 plus 2 is 8, plus 12 is 20, and our radical stays the same, so 20 cube root 4. And that's our solution. So on the next page, you guys have a chance to try a couple on your own, so go ahead and give those a try. The solution is at the bottom, so you can check your answers there, and then you guys have a little assignment to work on from the textbook. So that's everything for today. Nice quick lesson. And next time we will look at lesson 4.3. Lesson 4.3 I've actually divided into quite a few sections. So you might have thought you were getting away with a nice quick chapter, but I've divided it into several shorter lessons. So I will see you in that lesson.